what is the mechatronics. So what is the mechatronics? Mechatronics is nothing but controlling a mechanical system using electronic controller. The electronic controller consists of sensors, which is also called feedback sensor. Note down. It is called as feedback sensor, which is used for controlling the machine, which provides the system output. Or a mechanical say you wanted to, for example, take a motor, you want to control motor speed. The motor shaft speed is called as the output. Input is a voltage. You are applying voltage to your controller. So by varying the voltage, you can change the speed of the motor or RPM of the motor. That will be measured using a speed sensor, RPM sensor, and that is given as a feedback to the controller so that it can maintain the speed of the motor, what is desired speed. We will see the what you call a closed loop control and open loop control later when we talk about control system also. So it has sensors, it has actuators. Without actuator, no system can do some work. So it has actuator. Then it has one embedded controller, which is also called electronic control unit. Basically, it is a small computer with a CPU, memory, and related this one. And of course, you write an algorithm, which you call a control software. In any language, you can write in C, Python, some other this one, compile and store the information inside the memory of the electronic ECU, so that this one. As I told you, the control algorithm will be developed. Right? It can be a closed loop control or open loop control. In closed loop control, you can use what you call a P controller, proportional controller, or proportional integral controller, or proportional derivative controller. If you want to still better control, you can go to proportional integral derivative, you call PID controller. So, or you can use fuzzy logic or adaptive control, that is called nonlinear control algorithms. And you may go for even deep learning, very advanced control nowadays, depending upon the requirement and the cost, which you want to do it. So you may develop control algorithm, which is called a software module. It will be developed as a software using C or C++ or Python or MATLAB. Any whatever lab software is convenient, you can use the software, write the control algorithm, compile it, generate what you call .exe file or executable file that will be stored inside the ECU of this one. This is done at the factory. Whole thing is done by the factory. User cannot do anything. In mechatronics system, the control software is developed by the company which makes the product, and they compile and store inside the ECU. ECU can execute the control algorithm only. User cannot change the program. He cannot delete and modify the control program of a mechatronic system, which is stored in this one. That you have to do this one. And of course, as I told you, nowadays, if you wanted to improve the this one full automation, correct, then you use automatically artificial, what you call AI. So the electronic controller can say all this thing: sensor, actuator, embedded controller, also called ECU, and control algorithm, and if needed, AI also. Again, the software. Please note, control algorithm and AI are written as software module and will be stored inside the electronic control unit memory. Because electronic controller unit has a memory, we are going to see that. What is the ECU or embedded controller? 2 to 3 classes. So on nutshell, I can say that mechatronics is nothing but integrated product development. Why? Because the modern machines, any machine we saw, starting from camera, washing machine, home appliances, then robot, industrial robot, or satellite, most advanced thing which is going to use for communication purpose or TV broadcasting or whatever purpose, or interplanetary exploration satellite, or lastly we saw IC engine, correct, which is a part of the vehicle. But please note that in the vehicle you have brake system, what you call ABS, anti-lock brake system, assisted steering system, then automatic transmission, which changes gears automatically, then engine control, and apart from that, what you call as self-driving vehicle or driverless vehicle, which is the future of automobile industry. It is going to come. People never thought it will come. When it was coined some 20-25 years before by Google company, or even before that, people did research. They said it will not work. They just stopped it. But now Tesla is commercially selling autonomous self-driving cars. So it is going to be coming each and every vehicle. That's why even your company may be working. Correct? That's why we introduced a course called Introduction to Autonomous Vehicle. and already 2023 best student you have completed. The 2024 students will be doing next semester later. Okay, we are going to do that. So wherever you see a mechanical system, there is an automation. Automation means there is a electronic controller is there. Electronic controller means it will have sensor, actuator, embedded software, and electronic hardware ECU and control algorithm as a programs. So combining a mechanical system with electronics called mechatronics. Already we saw with many examples. So it is, you can say that mechatronical integrated product development. We'll see what it is in subsequent slide. Okay, if you want to develop a mechatronic system, you should have knowledge. Basically, it is a mechanical system which is controlled by electronics using sensors, actuators, and control algorithm. So you need knowledge of mechanical system design. Being a mechanical system, you need a mechanical engineer who is going to design each and every component of the mechanical system. If you talk about engine, for example, being an automobile engineer, engine means it has more than 200 part, 300 part each engine, correct? It has a piston, it has a connecting rod, it has a gudgeon pin, it has a crankshaft, it has a camshaft, inlet valve, outlet valve. Then you have the engine body, which is correct. Then cylinder head, bearings, correct, flywheel, then bolts, nut, which is going to connect springs. All these things are individual component. So it has maybe hundreds of individual component, and individual component you will design. To design this mechanical system, you need a mechanical engineer. Then in fuel injection system, already we saw there are, if you talk SI engine control, you have fuel injector is an actuator again. Then spark plug is an actuator which is going to generate spark. Of course, spark plug with high tension coil, which is nothing but this one. Together they generate this one. You can say this is as one actuator. This is going to control spark, and this is injector going to control fuel metering. So these are two actuators. So that means you should know what injector. Fuel injector also is a electromechanical. Please note that fuel injector is a electromechanical device, right? So electromechanical device. It has a coil, it has a plunger, it has a spring, it has a nozzle. There's so many components. Inside that there may be around 20-30 parts. All those things. Please note that injector itself is a mechanical system. To design injector also you need mechanical engineer. Inside it you have a coil, you supply voltage, it produces a magnetic field. The magnetic force opens or closes the fuel plunger or needle valve of the injector. So fuel is controlled. Quantity of fuel is controlled. So that means you need an electrical knowledge to design the solenoid. Then you need a mechanical knowledge to design the injector itself. It has many mechanical parts. Okay, so to develop, that means you need an engineer who knows electromechanics, correct? So then you need sensors. Already we know that we have TPS sensor, EEGO sensor, correct? Engine speed sensor. Then the inlet air temperature sensor, map sensor, manifold. So there are many sensors used in fuel injection system or mechanical system. So you need an engineer who can design the sensor. You need an instrumentation and control engineer, instrumentation engineer who can design sensor, all those things. Mechanical engineer doesn't have knowledge, correct? You are not taught on that or trained in that. So you need to work with him. Then finally, the entire machine is controlled using a lot of software, control algorithms and other algorithms. So you need a software engineer. That means a computer science or IT engineer is needed. Correct?
Professor, sir, sorry to
Yeah, yes,
interrupt.
please.
We are seeing your PowerPoint screen, but whatever you're writing, it is not visible.
Well, it is not visible. Okay, 1 minute. Let me again. Now it is visible.
Yes.
Yes, sir.
Okay.
Yes, yes.
Okay. Thank you. So somebody mic has to be switched off. There are a lot of background noise is coming from somebody. I don't know. because he may be traveling, I think, because a wind sound is coming. I don't know. All of you mute your mics. Okay, so you need software engineer. That means who can write program, all those things. We say computer science engineer or IT engineer, but you can also learn. It's not the only computer science. Even you can learn all these things. Then, of course, you need knowledge on data acquisition, all those things. Sometimes because you have to store the data, store the information, again transfer to something else. Apart from control system development, correct, all those things. So you need different engineer. Apart from mechanical engineer, you need actuators design, sensor design, software development, and also the ECU development, electronic. That's what it is. Data acquisition, processor, and controls. And these were electronic hardware. That means you need an engineer who can design your ECU. What type of microcontroller, what type of memory, you have to make a PCB, all those things. The hardware development, we call it hardware electronic hardware development. So all the engineers work together, then only can develop a mechatronic product. Yeah, just one engineer, mechanical engineer. There is nowadays there is no just mechanical product. That period is over. That's why I gave starting from home appliance, a washing machine, correct? It is fully electronic. At least 30-40% cost goes to electronic sensors, all those things. Of course, you need mechanical system, correct? Without mechanical engineer, no product is there. Any machine, what we are talking, whatever item you are having, some shape, some components is nothing but a mechanical system that need mechanical. But everywhere automation, more electronic, more software, everything has come. Okay, so that means we call a fusion of mechatronics, nothing but fusion of engineering. That means mechanical, electrical, electronic, control engineers, software engineers needs to work together to develop integrated product design. Because if I want to develop an engine, correct, new engine for your car, whether it's a two-wheeler engine, four-wheeler engine, your company, you are part of that. You'll be working with because it has a fuel injection system. In fuel injection system, it has sensors, actuators, and also software development. Apart from, you will be developing engine. In the engine itself, there are many components. Even if you are capable of developing all the components, of course, you need a big this one. You need a mechanical engineer. Mechanical engineer alone cannot develop a modern engine for any automobile, any engine. Marine applicable, all these things, because now lot of automation and is gone in. So automatically, you need electronic software, sensors, all those things. That's what the mechatronic we want to talk. So now that we are gone for more than 8 to 9 classes, we will define what is the need for a mechanical engineer. Right? Mechatronics was started in Japan and later it moved to Europe. Finally, now everywhere in the world. As I told you in the beginning, it was first introduced in the Escova electric company in Japan, 1969, by engineer called Tesuri. Correct? If I am correct, don't remember, but he only the kind word, because they were developing a mechanical system, they want to automate using electronic circuit. He only coined mechatronics word, mechanical system controlled by this one. From Japan it is now everywhere, because wherever electronic, please note that this automation is there for last 100 years, correct? Even before that, mechanically you can make automatic using gears, links, all those things. You can automate machines. There are machines, automatic lathe. In IIT we had a lathe which was imported from Germany 1970-80, where you can make components. They did not have a computer. It had a lot of gears, all those things, you can program it. Mechanical calculators were there before electronic calculator. So it is there, but now you are becoming more electronic, all those things. So gaining acceptance in industry, and also now you have mechatronic, BTech, mechatronic, PhD in mechatronics, because mechatronic become part and parcel of industry and academia. That's what I want to say. In the past, machine or product design has been domain of mechanical engineers. I'm talking machine or a product. I'm talking mechanical product. There were no electronics, no sensors, no control system, no computer. So it was pure mechanical. I don't need any engineer. I always used to say that it was like 50 years ago, go to Ambassador Car Factory, Hindustan Motors, correct, which was making Ambassador car for a very long time. Correct. So there, what is there in the Ambassador car? No electronics, no computer, no software, no sensors. It has some diesel engine or petrol engine, correct? Gearbox, then steering system, body, transmission system, differential, everything is mechanical. You go to that industrial motor factory, if there are 100 engineers, 99 engineers, 95 engineers will be mechanical engineers, automobile engineers, because we don't need electronic computer, nothing. Correct? Only electronic available was if it is a petrol engine, you had the spark system, spark plug, high tension coil, all those things, and apart from headlamp, horn, and maybe some other lamps, correct, inside the cabin. Nothing more than that. If a diesel engine, you don't need even spark plug, correct? Only you need headlamp, tail lamp, nothing more than that. And starter motor. Many times you have a starter motor or a fuel pump, being the sun to suck the fuel from the tank to pressurize. In case of diesel engine, correct, you need a petrol engine, there will be a electric motor. No need for electronic sensor. Still, ambassador cars are running in India. You can go Premier Batmi. I call it an old generation car. So that means I don't need. But now everything has become automation. Correct? Automation to increase the efficiency of the machine, which is not possible only using electronics, that is mechanical system. Correct? You cannot meet Euro standard. You cannot increase fuel efficiency of your engine. To get more mileage with carburetor, impossible. You can make it, but you may not meet the this one regulation, Euro Bharat 6 regulation. Meeting the regulation, also maintaining the maximum mileage, efficiency, all those things possible only using electronic and fuel injection system. Correct? That we have to accept. That is why it, because everything is in. That's what I am talking. Then in previous this one, engineering was sequential engineering, opposed mechanical design. If you want to make an engine, correct, what you'll do is somebody will make a gear, correct, for example, cylinder block. After making cylinder block, then you make pistons. After that, you make crankcase, all those things one after another, correct. So then you assemble things. Sometimes you can do parallelly, but it is an approach and which was not optimal. Well, correct. Or for example, you make one say subsystem, after that make the other, and third one, and finally integrate, because we don't know whether the system will work. I'm going to talk about it. That is called a typical the mechanical system design or conventional machine design. We are going to talk in next slide. That time we'll see. So the sequence of resulting less optimal performance design, which are time consuming. Yep. If you want to develop a new car or new model car, it may take 5 years, 3 years. I'm talking this one. I'm some 50 years. Nowadays, you can bring out a new car model from the scratch within 1 year also. Right? Because everything is computer, modeling, simulation, everything you can do, optimate design, bring out the prototype within 1 year, next year you can launch. That is called as mechatronic design. We are going to see that. The prime role of mechatronic is one on initiation, integration throughout the entire design process of mechatronic engineer as a leader for the team. Correct? Nowadays, modern, any product you want to make means you need a mechatronic engineer. Not mechanical engineer, not computer science engineer, not electronic engineer, not the software engineer. You need a mechatronic engineer. What mechatronic engineer? You should know everything about this. Correct? If engine means, you should know what fuel injection system means. What at least you should know what the ECU means, what is inside the ECU, microprocessor, what microcontroller, what type of microcontroller, whether you need 8 bits, 6. You should know overall knowledge about this one. He only can be a leader of the product development, not a mechanical, not electrical, not possible. Because mechanical parts may be 40% of the product. Correct? Another 20-25% the electronic engineer, another some 10-15% sensor, another 15% software control engineer. Correct? He only knows. Without him, you cannot do. That means if you want to be a leader of a design team, you have to be mechatronic engineer. Even if you have done a BTech mechanical, if you want to, then you have to know all electronic everything. Additionally, you have to study. That's what mechatronic means. Otherwise, you cannot lead the project team efficiently. You can lead all those things, but definitely you may not do it efficiently. Suppose wantonly, electronic engineer delays developing the product, correct, in your team. He said this is not working, that is microcontroller programming, all those things. You being a mechanic, what you will do? You go and see the program, you don't understand. He talks about microcontroller, hardware is not working. He shows some signal, all those things not correct. You just being a mechanic cannot ask him. Unless you know about how it works, at least may not be expert, at least you should be able to understand, then only you'll be able to get work from him. correct? Otherwise, if you wantonly doing, I'm giving you, because I have met a similar person when I was in industry in 24 years before, correct? So I was the project leader, and in project leader, that for another team member was there. Because he was a software engineer, I told him once that I worked in IIT 20 years, then I went for industry for 2 years. That time I know about hardware, ECU development, engine, all those things. Already I've done a lot of things. I have not developed much software. Developing software, C++ programming in IIT, that's not my job. Right? I told him that that employee who was in my team, I was the leader. You are working. He mistook that I don't know any software, and I gave a work. How long it take? He said 2 weeks. Correct? You are dragging. Once I asked him, no, sir, this is not working. That is not working. When I compile, it is giving error. Correct? He was thinking that since I did not do, I told him only once. I have written program, not much extensively. He thought that I don't know. Correct? But then one day I called him. Can you run the program and do the comparison? We'll sit together and debug the program. Within 3 hours, I am able to make it work. And after that engineer stopped this kind of gimmicks or mimics. Right? If you give the work immediately, complete within the prescribed time, you'll do, because he knows that I know software. I also know software, not only hardware, all other things. I know I can sit and debug the code. Right? So if you want to be a mechatronic engineer, you need complete knowledge. That's what the last sentence means. Mechatronic engineer will be a team leader. Only he can succeed, making everybody to work and bring out a product quickly. Okay, if you see a mechatronic system, what and all you have? You have a mechanical system which is called as a plant. Right? Plant or system, this is the name used. Note down, it is called a system. The plant or system can be a robot, it can be a AGV or a CNC machine, anything. Any product, we have mechanical product which is controlled by electronics and software is called mechatronic product. So that product will have mechanical parts. Correct? It can be vehicle engine, it can be consumable like a washing machine or a microwave oven, correct? Or any other machine, dishwasher in your home or Xerox machine, any machine where our automation is there, correct? So conveyor belt system, assembly system, that's what I'm saying. It is not limited to what I shown you. Plant or system, which is a mechanical, which I wanted to control. So this is mechanical design. Then the machine will not work on its own. Machine will work only if you have the actuator, correct? If you talk about car, the actuator is nothing but the engine. Without engine, car will not move. You have gearbox, you have body, you have the steering system, you have suspension, everything is there. Engine is not there. What do you use? It is a mechanical structure. Just only you can't, it won't move, because you need an actuator which is going to give torque to push the vehicle forward. So in your car, the actuator is nothing but the engine itself. Right? Similar to that, in any machine, there will be, it can be a motor, it can be electric motor, hydraulic motor, IC engine. If we take an aircraft, correct? Aircraft is a mechanical. It has a wing, ailerons, there's a lot of components. Everything is there. If engines are there, it won't fly. Engine is nothing but actuator, jet engine, correct? So like that, it can be electric motor and this one. So you need actuator, then you need a controller. The controller is nothing but a small computer which has a CPU, like your laptop or desktop. It has CPU, it has a memory in which you store the program. Operating system will be there, which is called as RTOS, real-time operating system. Generally, in your computer, you have the general purpose OS, GPOS. General purpose OS is nothing but like Windows, correct? Ubuntu, or any computer you are seeing anywhere. It can be a laptop, desktop, mini computer, supercomputer. It has operating system. That is called a general purpose operating system, because the computer, what you have in laptop, is called general purpose computer. Why it is called general purpose computer? Because you buy a laptop, for example, with i7 processor, it has a CPU, i7 CPU, it has a memory, for example, 4 GB memory, and it has, for example, 1 TB hard disk, and the display, 14-inch display, and a keyboard. Correct? So keyboard is called input device, the display is called output device, the i7 processor is called CPU, correct? The 4 GB memory with the TB is called the memory of the system. Any computer will have, whether big or small, make a pocket computer to the supercomputer. You will have a CPU, you will have a memory, you will have an output device, correct? Output device can be a printer, plotter, or a screen on which you are seeing the output of the computer, and input device like keyboard, mouse, all these things. So including similarly even mechatronic system also what you call embedded controller. Embedded controller also in general purpose computer called computer, correct? In case of machine control mechatronic system, the controller is called a embedded controller. I will tell you why it is called embedded control later when we talk about control system. And this embedded control system also has hardware like computer. You see, if you buy a laptop without Windows, it won't work. Correct? Windows has a motherboard inside which is CPU and memory, hard disk, power supply, all these things. We call it hardware. But if you don't buy the Windows operating, it won't work. So you have to buy Windows as a software. They're called OS, operating system. Actually the OS only is going to control your computer, not the CPU. Many times people say CPU is controlling the computer. No, the OS is controlling, which is nothing but Windows or Ubuntu, whatever the OS, that is what going to control all the components. Memory, CPU, input, output. All this hardware is controlled by operating system OS, which is a software. Without software, computer will not work. So who is the controller? Our main component of any computer is operating system, not the CPU, all those things. CPU used for executing software, right? So similar to that, in embedded system, you have operating system which is called RTOS, which is nothing but real-time operating system. Short form is RTOS. We call as RTOS. Okay. So that means embedded controller also is a small computer. Specifically, only one main difference is the software which is stored inside this embedded controller can control only this particular machine. The software, you will have a RTOS plus software, control software. Any embedded control system, you will have a RTOS plus control software. Sometimes very simple system is you will not have a RTOS at all. Directly control software alone will be there. Definitely there will be control software, which is going to control the machine. And how it is going to control? Based on the information coming from the sensor. Because the sensor called as input device. In your computer, keyboard, mouse, or the CD-ROM, all those things, correct? Through which you can pen drive, you can give the program, correct? Any program you can develop and store it and you can read it and do it. So in case of embedded controller, input devices called sensors. What is the output devices which is going to control machine? Actuators. So this is input device, this is output device, and of course the CPU will be there plus memory. Correct? Together it is called an embedded controller which is going to control the plant. So this is called a functional block diagram, a mechatronic system. Please note down this. In exam, you write about mechatronic system with the functional diagram is you show this and also the relevant other things also. Okay. So this is about overall mechatronics. That means a mechanical system with a controller, with a actuator and this one sensor. Inside which there is a software also, control software also inside. Okay, this is what gives the overall picture. Now, if I want to break down in a detailed way, I want to talk means we know that in a mechatronic system, you take, for example, I have a motor, electric motor. Please note that mechatronic system need not be a machine. Even a electric motor, it is made of motor is made of, correct, armature. It has a body, it has a field magnet coil, armature coil, bearings, shaft, all those things together you assemble only a motor comes. Generally we call it actuator, but actuator itself is a mechanical system. And if I wanted to control the speed of the motor, if I this one, I can say that I need electronic control, correct? So here I told you in mechatronics, many times they call as a plant or system or process. These are the names generally used for representing a machine or this one. Right? For example, if you have a petrochemical industry, cracking column, it is a big mechanical structure. There are pumps, heaters to heat the crude and cool the vapor and separate diesel, petrol, naphtha, separate this one, all these things. Lot of sensors, lot of pumps, all this should be considered. There are heaters, right? All these things also, the cracking column of petrochemical industry is a mechanical plant in which there are a lot of sensors, lot of actuators. Pump will be pump the crude at a particular pressure. All this thing will do. So that's why if you go and ask chemical people, they don't talk a system or this one. They call it as a plant or process. Mechanical called as system. Aerospace engineer call it a system. Plane is a system. CNC machine is system, engine is a system, correct? Electric engine motor is a system for you. So it made us this. Now, if you think that you are wanted to control a motor, correct? So this is my process, nothing but my motor. Let me clear this and you'll read it. So this is nothing but electric motor. I want to control the motor. What I want to control? The output of the motor speed, shaft speed. Shaft speed is the output of the system. This is my system, and I give some input, so there's output. If I give an input, there's output. What is the output? Torque and speed or RPM of the motor is the output parameter. Right now, I don't worry about torque. I am interested in a motor. This motor, if I give 0 to 10 volts, the RPM will vary from 0 to 1000 RPM. That's what the motor manufacturer. This motor I want to control. Now this is considered a mechatronic system because the bearings, all those things are there. I wanted to control. How I will control? By controlling input voltage. Input is vary from 0 to 10 volts. The output will vary from 0 to 1000 RPM. For example, I wanted to maintain 500 RPM. Correct? If I wanted 500 RPM, my input to output relationship is linear. Linear means this x-axis is voltage. Correct? 0 to 10 volts. Y-axis is nothing but 0 to 1000 RPM. Correct? If input is 0 speed, the output is 0. Correct? This is 0, 0. Now, input voltage I give 1, the motor speed will become 100 RPM. If I give input equal 2 volts, it will become 200 volts. Like that, if I give 10 volts input, the output will be 1000 RPM. Correct? So, if I plot the points and make a curve, you will see a straight line curve. Now, I can write an equation for this. Correct? Now, what I did, I wanted to find out if I give 0 volts, what will be RPM. I have a RPM sensor, correct? RPM sensor mounted on the motor shaft. I am measuring what is current speed. When I give 0 volts, 0 RPM. When I give 1 volt, it shows 100 RPM. If I give 2 volts, it gives 200 RPM. Like that, as I increase to 10 volts, it gives 1000 RPM. Now, I connected all the dots, I got a straight line. This is nothing but the mathematical model of my motor. Correct? Mathematical model of motor. How did you get the mathematical model? By giving input and measuring output. If you want to develop mathematical model, any system, correct? The only way to do is, there are two ways. One is using individual components, correct? By knowing the individual components, input output characteristics. Other one is by giving input and measuring output. I give set of inputs and find out what is set of outputs, then plot it. From that I can get you what is this? This is the equation of straight line. Correct? This is equation of straight line. Correct? Y equal to mx plus c. Correct? This is the model of the system. My motor, if it follows a linear this one, if I give 0 to 10 volts, and if the output is 0 to, and it follows a straight line, I can use. This is the mathematical model of my motor. Okay. Now, from this, I can develop further. Okay. We will see that how it is happening in subsequent class slides or this one. So now I have my process, which is nothing but motor. And now motor itself I consider, because many times I told you we saw many examples. For example, let me do little correction right now to understand purpose. I say my process is a robot. Correct. My plant is a robot. Correct. We already saw robot as links and joint. So that it has links and joints. By connecting links and joint, I got a mechanical structure. Robot is nothing but a mechanical structure. Correct. It has L0 link. There's a joint, rotary joint. This is L1 link. Then one more joint, L3. Correct. Then you have the end effector, EE. Correct. This is a 3-degree robot. Correct. Now what I say, L0. Sorry, this is L2, then a 2-degree robot, correct? So in this case, link and joint, this is R1, this is R2. They together, they form because they are individual component. When you connect, I got a robot, which is nothing but a mechanical structure. The end effector cannot move. If I want to move the end effector, what I do? I have to attach motor on each joint. I say M1 and M2. There are two actuators, correct? So that's what I said. I have mechanical structure robot, which is made of links and joint. It cannot do any work. It's just a mechanical structure. But it can carry load, carry all this thing, but it cannot do any work. If I want to do work, I have to attach a actuator. That is called a correction unit. In some books they are called actuator. Many books they are called as actuator. No doubt, correct? Correction unit you make into robot to do some work or machine to do some work, right? So it is nothing but actuator. So in this case, actuator I may use. Yes,
May
please.
I ask a question, sir?
Yeah.
As we previously defined here the process as robots and motors, many a time they themselves are the actuators, no, sir? Or like, are we referring to the end action done by the robot as the process?
No, the actuator I am talking about giant motors.
Okay.
Right? Giant motor, without giant motor, giant won't move. If you giant won't move, link won't move, then end effector won't move. End effector move only when giant moves, the links will move. Finally, end effector moves. Here I am attaching, for example, a load. The load should be moved from one location. That's what the end effector is going to do. Take this load, move it from one location to another location. The end effector will not move on its own. The link will not move on its own. Giant won't move its own unless you attach an actuator. That's what I'm talking. So mechanical structure is controlled by an actuator. That is called a correction unit. Okay. Then now if you have control as a digital control computer, the output from the digital control is a binary numbers. All the computer, the output is a binary numbers. That binary number cannot be directly given to the controller actuator. In this case, the robot actuator nothing but a motor, giant motors. Right? Giant motors. The motor one 0 to 100 volts or 0 to 10 volts. So the controller gives binary number in terms of digital number 1010 something like this. This cannot be directly given to motor. This should be converted into DC voltage. That is the job of the DAC, digital to analog converter. Note down. We call digital to analog converter. So the computer or controller, embedded controller output is a binary number which cannot be directly given to any actuator. It can be electric motor, it can be engine, correct? For example, butterfly valve you have to control, throttle control, correct? The throttle control is a motor, correct? You will use a DC motor or a servo motor. It wants a continuous volt 0 to 10 volts to open throttle 0 to 10%. So the number generated by the computer or digital control, embedded control, binary number, which cannot be done. So you need an additional device called DAC, digital to analog controller. So from the binary controller, the binary number is going to DAC, which in turn generate 0 to 10 volts. It generates 0 to 10 volts. As you give the input binary number in the x-axis, y-axis into this one. So this is how it converts. DAC is going to convert. Then, of course, we already talked about the controller. The controller can be, please note down right now, it can be analog controller or digital controller. Note down. It can be analog or digital control. There are two types of controller. When you talk about control system, we discuss it. Just right now, you note down. Then, of course, the most important part of any mechatronic system will be what you call a closed loop control. In the closed loop control, you have a device called error amplifier. Some books call error amplifier or some book called error measuring system, something. But that will be represented like this. Please see the symbol. It is like a buck sign, correct? A circle with cross, and it have two input. One is called plus, other one is minus. No doubt. I missed to where it is. Then the output is called error signal. One input, the plus input is called a reference input, correct? This is called a reference input. The other one is the input coming from the measuring device, which is called a feedback sensor. It is called as feedback sensor. Feedback sensor, which measures the system output, correct? System output in case of robot means it is going to find out the end effector position XE, YE, ZE. What is my reference input? I give XR, YR, ZR. I want to move my object from this location, right, which is to the new location, this location, A to B, correct, in three-dimensional space. So this place is called as initial by X0, Y0, Z0. That is called origin. From here it has to go to new location. I can say that X1, Y1, Z1. So this is what the end effector has to move from here to here. Take this object, move this location. To move that, you have to control giant motors. Right? In the robot, what we talk, you have to control. The controlling is done by actuator. The joint is moved by the motor. The motor receives command from the computer, the controller. If it is a digital control, then you will have a DAC. If it is analog control, you will not. I told you the controller can be analog controller or digital controller. ECU can be an analog controller or digital controller, but modern all ECU are digital control. That's advantage when you talk about that, we'll see. Correct? Analog controller or digital controller. Digital controller means there's a small computer, micro, all these things. Analog controller means there's no computer, no ECU, no memory, nothing. It has electronic circuit, and we are going to talk about that later. So if the digital controller, DAC will not be there. If the analog controller, digital means you will have a DAC, because the digital controller generates binary numbers, zeros and one. That should be continuous signal, which is called a 0 to called analog signal. The digital signal will be converted to analog signal by the DAC. Okay. So then you have feedback sensor. Feedback sensor measures the system parameter and gives us another input. Now, if the sensor, the feedback sensor is an analog sensor. Please note that sensor also you have analog sensor as well as digital sensor. Note down. Most of sensors are analog sensors. For example, thermocouple temperature sensor. If temperature varies from 0 to 1000 degree, the thermocouple gives 0 to 100 millivolts, which is a continuous signal. That if the signal is coming continuously with respect to time, like an analog signal, instead of that, sensor provides a binary number. Correct? It is measuring force. Force is measured from 0 to 10 Newton. Correct? 0 to 10 Newton. 0 Newton is called as 0, 0. If they correct, all 0, 8-bit number is this one. And the 10 Newton is represented by 1, 1, 1, 1, 8 ones. So if it is 5 Newton, it will be 1, 0, 0, 0, 0. Like this, there are 256 steps. It is there. This is called a binary number. So my sensor measures the force 0 to 10 Newton and provides a binary number 0, 0, 0 to 1, 1, 1, 1. Correct? If this number is called binary number directly, in that case, I don't need ADC. ADC is called as analog to digital converter. DAC is called digital to analog converter. This is called ADC is called analog. What is this? Most of the sensors don't produce digital output or binary output. Right? They are not digital sensor, they are analog sensor. That means they will generate 0 to 10 volts when the parameter measures 0 to 10 Newton force. Correct? A force sensor input is 0 to 10, it generates a signal 0 to 10 volts. That voltage cannot be given to digital. If your controller digital controller, you cannot give the sensor analog sensor output directly. You need the ADC. In that case, you need an ADC. Okay. So then the ADC converts to binary signal. Analog signal is converted to binary signal, which in turn is given to the controller. Right? Which in turn is given to controller. So the controller does. So what is the job of the controller now? Sorry.
Professor sir,
Yeah.
just one query. This analog signal is continuous signal, right?
Yes.
And digital is just binary.
Yes. Digital is binary.
So
it represents 0 volts or 5 volts.
So if we are feeding computer, then analog signal has to be converted to binary, and hence we have to use
the ADC.
ADC.
ADC. See, your signal, most of signal coming from sensor, all those things are analog signal. So computer doesn't understand analog, it understands only binary. So then you need to have ADC, which converts your analog signal binary and feeds it to computer. And you process inside the computer. Then the output, because in the Mechatronics system, the output needs to be given to actuator. This actuator, correction unit, always generally 99% of the actuators want analog signal, analog control signal. Motor, engine, correct, or jet engine, or servo, for example, hydraulic motor, the control signal generally want analog control signal, correct, continuous signal. So the computer generates binary number, so that cannot be directed. Then you need a DAC.
Right, sir. Thank you so much.
Binary to analog is done by DAC. Analog to binary is done by ADC. From the sensor, the analog signal comes converted to binary and given to the digital controller. Please note that if you have an analog controller directly, you don't need both these things. Your system becomes simpler and cost effective. But Digital control, analog control is faster. There are a lot of advantage, but it has a defect also or disadvantage. It cannot. If I want to use same analog control, cannot be used for different machines. For example, I have washing machine. Correct. I have a microwave oven. Both I am making in my company. Correct. And if I have a digital controller, an embedded controller, then it can be programmed to control washing machine, or it can be programmed to machine my microwave oven. Or it can program, if I automobile company, you have ECU, you can use it for controlling engine by putting appropriate engine control software. Same, I am talking about hardware, correct? Like a computer. For example, take a computer. You can install Windows operating system, or if you don't want to delete that, you can put Ubuntu. You can design. Similarly, because the same computer, correct? Same computer hardware, you can install any of the operating system, any of software what you want. Similarly, if I have digital controller, I can put any control for engine control software. Same ECU will work for controlling engine. Instead of delete that program, you put a, for example, steering control software. It can control steering system. Instead of that, I put a ABS software. It can control the ABS system. That is the advantage. Changing this same hardware to make it different, very simple. Delete the program, put the new program over. But if it is analog computer, the computer itself, the circuit itself should be changed. You have to design new computer for each product. Washing machine, separate computer, analog computer. For this one, microwave different, engine control different, say transmission control different. So that means the whole controller you have to change. That is the drawback of the analog computer, but they are very, very rugged, very good compared to digital control. Inside speed, all those things they are good. But the drawback is you need to design every time new analog computer. Digital computer, they can have a common software. So you buy a laptop today, you use for 5 years. You use different software, delete it, virus comes, you format it, again you can use. That is advantage digital control. Correct? But it has some drawbacks. But the drawbacks are much simple, can be ignored compared to advantage digital control, because same hardware can be used for controlling different machine. Okay. Now I'll just take 2 minutes to complete. Okay, so you have mentioned this. Please note down the functional block diagram. Correct. The controller can be implemented using different type of control algorithm, which is called proportional control. P means proportional controller, I means integral controller, D means derivative control. Generally, you will have a P controller or PI controller or PD controller or PID. You will not have I controller or just I controller or just D alone, but you will have P control alone. Correct? It's called proportional control. Then you have feedback sensor, and this is the actuator. This is your plant. Here the quadcopter. Correct? So this is my plant system which I wanted to control. Quadcopter consists of 4 rotors and 4 motors are there. Correct? For the rotor speed, if you control the position of the quadcopter flying, it can fly any direction. All these things you can control. For that, I am using a PID controller. This is my control system. The PID can be implemented using digital controller or using analog controller. We will see all the things later. Okay. Any questions till now? No question. Okay. So next class, I will stop here. In the next class, we are going to see components of mechatronics system, control system. What are different type of sensors are there? What are different type of actuators? And all those things we'll see next class. I'll stop here. Okay, you can give attendance, you can log off. See you on Monday. Thank you.
Thank you, sir.
Have a nice weekend. See you on Monday.
Thank you, sir.
Thank you, sir.
Thank you, sir.
Yeah, you can log off.